Okay, for the purpose of this video, I will show you how delta math works. The first three skills, which are the volume of a cylinder and volume of a cone and volume of a sphere, will require you to use the formulas that are given to you on Brightspace, as can be seen right here on the first page of Brightspace for geometric elements. So let's take a look at it. Volume of a cylinder. In these questions, they might give you the radius, and when you have the radius, you just have to use the calculator that is already provided for you. Use the formula for cone. We're doing right here volume of a cylinder, so we're going to use cylinder formula. So what you have is you have to click pi times radius. Well, in this question, we're quite lucky. It's giving us the radius of 2. So 2 squared times the height, which is the height of the cylinder, and that number that is given is 11. When you type that in, you get an answer, and it's going to ask you in quite a few of these questions to round to the nearest tenth. In this example, we can round 0.23 to 0.2, as 0.23 is closer to 0.2 than it is to 0.3. That is the tenth of a decimal, so we can submit the answer and check. Okay, look at another problem. If you are ever going to be given a question that says diameter, you must remember that the diameter of a circle is not the radius. It is not what you need. The diameter is measuring the punto a punto in a circle. So if we're told that that is 12, we are going to need to have the radius, meaning el centro until the end, which in this case is always half. Yeah, the radius is half of the diameter. It's always going to be half. So knowing that that is the radius, you can then type in the following into your formula. When you are working on these skills, a nice little hint, you don't have to type the question in every time. You just have to change one number and change one number. Look at that, 18. So we don't have to type it in every time. And there we have our answer, 2035.75. That is going to be the height of our cylinder times the radius squared, 6, not 12, 6. And when it's asking us to round to the nearest tenth, well, 0.75, anything that has a 5 will be rounded up to 8. Yeah, because it is closer. 0.75 is closer to 0.8 than it is to 0.7. We can submit that answer and check. Okay, so I hope the volume of a cylinder makes sense to everyone now. Another skill that we're going to take a look at is the volume of a cone, exactly like you saw before. These questions require you to use the formula that is given. So just for the purpose of simplifying it, we're going to actually already type in the formula. That way we don't have to constantly type it in. 1/3 of, what is it for a cone? Pi, 1/3 pi, times, what do we have here? R squared. So we can type in the letter R to the power of 2 times, what else do we need? The height, H. So now that we have the formula there, well, we're just going to read the questions and see what we need to type in. So we already are given the information that the height is 11.5. So let's go back to the calculator and type in 11.5. And we are going to be given that the radius, oh, look at this question. It's giving us the circumference. There's not much we can do with the circumference here. What we can do, however, is use what we know already, and you should have learned this with Herman already, that the circumference of the circle, 2 times pi times r. Well, what do we need for the area, for the volume, r? So we can divide both sides by 2 pi. Divide both sides by 2 pi. So we need to actually divide 16.5, as that's the circumference, by 2 pi, and that's going to give us our radius, exactly what we need. So let's go back to the calculator and divide 16.5 divided by 2 pi. Okay, so now it's giving us the number that we need for our formula. And if we just copy the following below, we just have to change R for the answer that we have above. And here we have it, 83.0449. So knowing that it's 83.049, let's see what the question is asking us. To round the answer to the nearest tenth, meaning that 0.04 is going to round to 83 because .04 está más cerca de 83 que .1. So 83. Type in our answer and we have it as check. Please remember to read carefully. If it says circumference, you have to divide it by 2 pi to find the radius. Okay. Looking at the next question right here, the volume of a sphere, Now, with the sphere, you do not need the height. All you need is the radius. And what you know, this question is giving us, once again, the diameter. And what do we know about the diameter? It is half of the radius. So our radius is 2.5, because 5 divided by 2 is 2.5. which is our radius, the information that we need. So knowing that that's the radius, let's take a look over here at the volume of a sphere, which is going to be 4 divided by 3 times pi times r cubed. So we can just simplify that by actually typing in the formula already. 4 over 3 times pi times, well, what do we need? We need the radius to the power, click the button right there, to the power of 3. What do we know about the radius? Well, we just said it was 2.5. So let's change r right here for 2.5. Okay, and there we have our answer, 65.449. So if we copy that number over down here, let's see what it's asking us. To the nearest tenth of a cubic. Well, punto 4, right over here, 0.44 is closer to punto 4 than it is to punto 5. So we just take away the punto 4 and we submit our answer. I know, what did I do here? Geez. Chicos, I did not read the question. You must read the question very carefully. Hemisphere. It is half of a circle, a hemisphere. This was a teacher error right here. Teacher error. That is a hemisphere. Okay, it is half of a circle. It is half of a circle. 1/2 of a circle. If we were talking about a full sphere, we are talking about a I hope this makes sense. A sphere, yeah, like the world, yeah, un globo, I like to maybe think of it, which is a full circled spherical object, okay? So please read and watch out if you ever see the word hemisphere. Let's do that question one more time. Let's check it out. Here it is, a new question. The hemisphere, meaning half of the world. So the equation that we're dealing with is not going to be v equals 4 over 3 pi times r cubed, because that is for a sphere. We're dealing with a hemisphere, and a hemisphere is just going to be the following equation, v equals 4 over 3 pi times r cubed, but what we must remember is that it's going to be multiplied by 1/2 because it is half of a sphere. So let's take a look at that one more time. The diameter is 7.4. Well, what is the radius if our diameter is 7.4? 7.4 divided by 2, which is going to give us 3.7. Yeah, so 3.7 is what we have for our radius. So using 3.7, yes, we're just going to type in back in the calculator the actual equation, but we're going to change 2.5, which was our R value, which is our R value, for 3.7. 3.7. So now that we have 3.7, we can actually put brackets around this using the brackets function and multiply the whole thing by, well, half, right? Mitad, which is another way of saying 0.5. I can also put in 0.5. It's the same answer. And when we do that, we can see that we're going to be given the correct answer this time. Please read carefully. I did not read in that question carefully, and you see that an error occurs. 106.087, so 0.08. Now, 0.08 is closer to 0.1 than it is to 0. So we say 0.8 and we enter. There it is. Now, there was an error because I did not read hemisphere. Notice that in some of these, when it says sphere, well, you can use the formula that you already have. If this is 48.6, then we just have to change this and take away the 0.5 because it's not a full sphere. It's actually a hemisphere, and just put a division right here of 3. Take away that 3. Okay, there we go. And the radius that we have, well, in the question, it was giving us 48.6. So therefore, we can say 24.3. Change that number of R, of R to 24.3. Let me just double check that it was 24.3. Yes, it is. And that gives us our answer right here. Now, let's take a look what it's asking us. It says round it to the nearest tenth of a cube. Tenth, meaning 0.56 is closer to 6. And we can enter in the formula. Please read those questions carefully when it says volume of a sphere, as it is very likely they change the word sphere, and sometimes they might give you the word, as we see here, hemisphere, which is half of a globe, mitad de un globo. Okay, so that covers the first 3 where you must use the formula. Now, in the following, you have the volume of a sphere level 2, the volume of a sphere level 2. Now, in this one, you're going to have to read carefully because it's either going to ask you for diameter or it's going to ask you for radius. Now, in this example, we're going to use the diameter and what's already given to us the volume. So, knowing that the volume of a sphere is 4/3 of pi times r cubed, well, we can actually reverse engineer this and say that the volume is 345, which equals 4/3 pi times r cubed. Teacher, what do we need? You need the radius. So you're going to divide the entire formula by 4/3 pi. Divide by 4/3 pi. So when we're doing in the calculator is 345. Let's type this in, 345 divided by. Well, you can type in exactly how you have it because this calculator is very friendly. We just need to divide it by 4/3 pi. Excellent. And there is our answer. Not quite, because 82.36, when you divide this result, you get, 82.46 is actually equal to r cubed. How do we get rid of this? Well, when it says square root, you can take the cubic root to the power of 3 of a squared root, and you get r to the power of 3. That way you are actually canceling out the 3's and leaving an r. However, you need to take that to both sides of the equation, so 82.46 cubed. And let's type that into the calculator. All you have to do, chicos, la única cosa que tenéis que hacer when you divide by 4/3 pi, is click this button, square root con un n, square root with an n, and type in 3 because we're taking the square root of the power of 3, and type in answer. And there you have your answer. Let us see what it's asking us here. Round it to the nearest tenth of an inch. Well, a tenth of an inch means that 0.35 is closer to 4 than it is to 0.3, so 4.4. And Jesus Christ, David. Pascual, vamos. Chicos, let's look at that question again, because what we just worked out was the radius. And your teacher is trying to do this very quickly and not reading it carefully because it is asking us for the diameter. So this result of 8, let's copy that again, yeah, must be multiplied by 2. Yeah, so we can type in the answer and whoops, daisies. What just happened here? Nope. We can do the answer multiplied by 2. And that will give us 8.701, which clearly, now you're going to see it. If we type it in, 8.701, 8.7, there we have the correct answer. I did not read that carefully, so let us do one more of these problems just so that it makes sense, because some of these might include a hemisphere. Some of these might include a hemisphere. Let's take a look. Here it is. Oh, there it is. So in this one, and this is a trickier one, when it says hemisphere, we know that we're going to be looking for the volume of 1/2 times 4/3 pi r cubed. Okay. Volume equals 1/2 times 4/3 pi. Well, what is the radius? That's what we're going to need to look for, cubed. However, we already know the volume. We already know that this is 921. 921. So if we know that that's 921, let's multiply it by 2. Let's multiply it by 2, which will give you 1,842 equals 4/3 pi r cubed. What do we do now? Well, now we're treating it like a sphere. We're going to divide 1842 by 4/3 pi, just like we did earlier, 4/3 pi. And that's going to give us a result in the calculator of, well, let's check it out. 1842 divided by 4/3 pi, and that's going to give us 439.74. Excellent. What do we do now? We're going to use it and take the square root to the power of 3 and use our answer that we have above. So 7.60. And it's asking us in the question to the nearest tenth of an inch. Well, that's 0.6, right? 0.6 of an inch. And there we have our answer, 7.6. So please read it carefully if it says hemisphere or if it says radius. Not all of them are going to ask for the radius. Please read those carefully. Okay, on the other note, what else? Let's look at the next one. This one is known as the click-click activity, the click-click activity. What you must do first, well, the points are already given to you, so that's very nice of them, is just to make a click and crear un triángulo. Click and click and click. And look at that. When you have the triangle, you must count the squares. Does it make any difference how you are counting, whether leg 1 is arriba abajo or whether leg 1 is left and right? No difference whatsoever. So now you just type in an 8 right here because that is 8 squares from left to right. And let's measure it from up to down. It looks like 7 squares. So if we know that that's 8 and 7, just use the distance formula that you already have in Brightspace. That's going to be 8 squared plus 7 squared. And as we practiced already, we're just going to have to add those two numbers together, 64 plus 49. And we're going to take the square root of 64, 59, 54, 55, 113. Okay, so 113. Now, is 113 divisible? Well, I don't really want to go through what you've already learned with Herman. Is it divisible by any of the following perfect square numbers? 1, 4, 9, 16, 25, 36. You must hopefully remember this. This is something 8th grade we're doing to this term. 64 And 64, 8 times 8, 9 times 9 is 81, 10 times 10 is 100. Is it divisible by any of these numbers? No, 113 is in fact a prime number, and you can always check by typing into Google square root of 113 simplified. And let's see what Google says. Nope, hence 113 is a prime number. So we clearly know that the answer here is going to be square root of 113. Type it in, enter, and there we have it, the square root of 113. These ones, I think you guys will do fine. Just remember, you must do click, you must do click, you must do click, you must do click. Once you have that, just count the squares. 8 to 1, that's going to be 7. 4 to 9, that's going to be 5. Use the following in order to create squares and multiply. Yes, the Pythagorean theorem in its finest. So 7 squared plus 5 squared, well, square root of 49 plus 25, that's going to be the square root of 74. So now the square root of 74, that is very likely to be simplified, chicos. That is very well likely to be simplified. You can always do it by the squared root or just type in the following, square root of 74, and look what it is. The square root of 74 cannot be simplified anymore. Yes, so we just have to type in to the following, the square root of 74. Ojo, sometimes you do have to simplify. And you can use what you've learned with Herman in 8th grade, or just type in squared number simplified and check it out. Okay, so I hope that covers that. Now, in the next one, density. Density as we have above right here. With the density, we're going to need to remember the formula that you already have on Brightspace. Where do you find it? Boom, first page, density, right next to the formulas that were already covered that we did in class. Density, mass divided by volume. So if we know that the density formula is density symbol, it's not accurate, but anyway, M over V, density. It's a nice little, that's somewhat the density symbol. Read the following carefully and hint, 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 hint. Read the following carefully. Hemispherical. We know that the volume of a hemispherical is something that is half of the following equation for a sphere. If that is the equation for a sphere, we have 9 cubed and 1 times 1/2. Now let's find the following that we have. We have a diameter of 15. So if the diameter is 15, we know that the radius must therefore be 7.5. Let's plug that number into the following. Now we have the volume equal to 1/2 of 4 over 3 pi times 7.5 squared. And now that you have 7.5 squared, you're just going to have to use the calculator that was already given to you. So let's type in the following. 1 divided by 2, open brackets, whoops, nope, open brackets. And we could just do 4 divided by 3 times, and click on the pi symbol, chicos. You cannot use 4.3 times 7.5 squared and close the brackets. And now that you have that, you have your answer, 117.8097. Well, we only need the 10th, so let's take the 100th decimal as well. And when we do that, we can type in that, but we're not quite done because we only know that the volume is 117.8. So let's type that in right up here. If we know that the volume is 117.8, and let's keep on reading to see what we have. If the water weighs 62.4 pounds per cubic foot, what is the total weight of water? When it says, chicos, total weight, it is referring to a word that I hope you will remember from physics, mass. That is the unknown variable, mass. But we know that the density is 62.4. So what are we missing? The mass. How do we get the mass? We multiply the volume over. So 62.4 times 117.8. Well, we can just go to the calculator, use what we already know, and say answer multiplied by the same number of our density, 62.4. And there we have it, 7,531.32. Copy that number over here. And when you copy that number, read it carefully to the nearest pound, meaning whole number. .32 is closer to .51. So we type in this and Okay, you know what? We did not use the correct formula. We're going to do this one more time. We're going to do this one more time, but do a different question of the same difficulty. These are a little bit easier. Hemisphere, there we go. Similar difficulty. Let's review this one more time. Hemispherical tank, diameter of 14. What's the radius? The radius must therefore be 7. What does hemispherical mean? 1/2 of a sphere, 4/3 pi times r cubed. So using that formula, what do? You type in 7 into r. And let's do that right here. What did I do wrong? Chicos, I didn't even type the equation right. Remember, it's cubed. Please use the formula. Please use the formula. Okay, so if we use 1/2 of 4/3, so let's type that in, 1/2 brackets, 4 divided by 3 brackets, pi times r to the power of 3. That's where we made the error last time. David Pascual. Almost. Okay, r. So what is it that we're being given in r? R is clearly going to be 7 because the diameter is 14 and the radius is always half of that number. So 7, we're just going to change the r right down here for 7. There we go. And there is the volume. That is the volume that we have. El volumen of a hemispherical shape. So we have 718.37. Let's see what the question was asking us for again. We have in the question, it is asking us for what is the total weight of a water tank, because it is already giving us the density. How do you know if it's giving you the density? If you ever see the word per. Per is always in reference to the density, everyone. So if we know that the density is 62.4, and we know that the fact of the volume, which is what we're going to look for, the mass, but we have the volume already of 718.37. Well, we just have to multiply the two numbers together as we did. 718.37 right here. I know. Enter, answer, multiplied 62.4. There's the number. Yeah, that's the number that we need for the mass. Copy it over. And if it's asking us for the nearest pound, well, 0.75 rounds up. So we type in a 7 instead of a 6, and there we have it. Okay. Don't rush it. Take your time, and above all, read carefully, chicos. It's all about reading. Okay, that covers density, okay? Please remember the formula. However, some of them are going to ask you for a shipping container, and these are probably going to be the easiest ones for you guys because a shipping container is a cuboid. Someone didn't know the shape of this earlier. I'm kind of surprised. It's a width of 10, a length of 4.5, and as it says, a height of 9.5. How do we work out the volume? This is probably a little bit too easy, but you're just going to multiply the numbers together. So we can go to the calculator, type in the multiplication, 4.5 times 10 times 9.5, and there is the volume, 427.5. So we know that the volume is 427.5. What else do we know about this? Well, it's also, the volume is equal to 427.5. So if it's also saying that the container is completely filled with contents that weigh 0.44. So in this case, as you can see, it's giving us the density. So what is it that we're missing? The mass, weight. So we know that 0.44 is equal to the mass divided by 42.75. Well, how are we going to find the missing variable, the mass, times that number by 0.44? So let's go back to the calculator. We can do that number, answer, times 0.44. And there we have our answer, 118.1. Let's see what the question was saying. To the nearest pound, everyone. You must read carefully, to the nearest pound. Okay, so we can say that's 188, and there we have it. These ones that will be a little bit nicer as they are just cuboids. Okay, now I'm going to do this one last, the water tanks, because that's a little bit of a longer one, but let's look at Pythagorean. All you must do here is use the distance formula, otherwise known as Pythagorean, and interpret the following situation. The area of a rectangle is 209, so we know that the area of a rectangle is 209. It is a width measured by 19, so we know that the 19 is the width. And we are looking for the missing, the value here, but it wants us to find the diagonal length. Well, how did we get to the number 209? That was 19 multiplied by something equals 209. How do we find that missing length that we are missing? Divide by 19, divide by 19. Now you have 209 divided by 19. So we can do 209 divided by 19. That's going to give us 11. So the missing length that we do not know is 11. Now that we have that, we know that the square that we're dealing with has a width of 19 and a length of 11. So what is it that it's asking us? How to find the diagonal. Use the Pythagorean formula, 19 squared plus 11 squared. So let's look at that in the calculator. 19 squared plus 11 squared. Let's look at that in the calculator. I'm just going to clear this stuff up so that it's a little bit nicer. There we go. 19 squared and 11 squared. So the square root of 19 to the power of 2 plus 11 squared. Oops, that needs to go inside the brackets. Watch out. It needs to go inside the brackets, not on the outside. Everything needs to go inside of the square root symbol. And there you have it, 21.95. So we just put that in, and it's asking us to the nearest tenth. Well, punto 95 is going to round to the nearest whole number, so 22. And type that in, and there we have it, the length of 22. 21.95 rounds to 22. Let's take a look at one more problem that we have here, because this is another type of a situation that it's going to give you. In this example, you must interpret the following situation. You have a ladder, which is always a diagonal unit that is leaning up against a building. So the building, I'm just going to change, and this is a building, okay. So there is the building, and we're given the fact that the building, yes, is going to have a height of 25 feet. So we know that this is 25, and we know that the diagonal ladder that we have is 36. Prepare yourself, because this is what you see in trigonometry all the time. You have a missing variable right here. Well, you know that the Pythagorean theorem is a squared plus b squared equals 36 squared. So how are you going to find the following? Well, we know that 25 is going to be one of those letters. Which one? It doesn't matter. It really doesn't matter. 25 squared plus b squared is equal to 36 squared. What are we missing right here? We are clearly missing b squared. So we need to subtract 25 squared on both sides in order to cancel it out. And now we have b squared is equal to this, well, I was going to do one step a little too fast, 36 squared minus 25 squared. And how do we get rid of that 2 right there? Well, to get rid of that 2, we're going to need to take the square root of the following. Take the square root of the following. If we take the square root, we're getting rid of the squared symbol. There we have it. So we're going to need to go to the calculator and type in the following that we have. 36 squared minus 25 squared. So the square root of 36 squared, and we just can type it in again. There we go, minus 25 squared, and there we have it, 25.903. Well, 25.9, let's type that in, and it's asking us to the nearest tenth. Well, we can just say 25.9 and type it in. There we have it. So I hope these are a little bit clearer now. You just have to use the Pythagorean theorem, which is an equivalent of the distance formula. You will definitely see this next year, and you will see these types of questions a lot next year. Okay, so the last one that you have here is comparing the volume in water tanks. Now, this little animation is interactive, and it will help you to interpret the question. Chicos, you must read this very carefully. You must read this very carefully, because all of these questions will just be asking you for the volume of a cylinder, and a cylinder is always pi times r squared times h. Remember, that is the only formula you're going to need to use for this. However, you will most certainly need to read this very carefully. If we read this carefully, we're going to take a look right here. And as we can see, we have container A. So I'm going to say A in blue, and we're going to need to find the volume of that. So if we're told that container A has a diameter of 22, we know that the radius must therefore be half of that number, 11. So pi times 11 squared times, and the height, well, we're being told it's 18, so 18. In these questions, you will nonetheless need to use the formula that is given to you. So 11 squared times 18. Let's use the calculator that we have here, and we're just going to go pi times 11 squared times the height of 18. And there we have our number for number 1. So the volume is 6,842.38. So we know that the volume is 6,432.38. Okay, that's number A. That is for section A, container A. You must read these very carefully, chicos. Read it very carefully. You will always need to calculate the volume of both cylinders. Now we have for volume B. Let's take a look at volume B. So we have the volume for B, diameter of 30. Well, what's the radius? We always know that's half. That's going to be 15. So pi times 15 squared times, what's the height? Well, we're given a height of 16 times 16. Now that we have that, we're just going to use the same, and this is how beautiful it is. If you already have it written, just take out the numbers that you don't need and change them. If you already have the formula written, just take out the formulas and write it in. There you go, 15. And there we have it, 11,309. And just to type in so that we see the second one, the first one that we did, the first one that we did, which is 11 and the height of 18. So we have both of them together. Now, read the question carefully, read it carefully. To the nearest tenth, what is the percent of container B that is full after pumping is complete? Well, look at the simulation. After pumping is complete, how much of container B is full? That means it's going to be asking us for container A volume, because there was more in container, less in container A, divided by the volume in container B. So let's use the following that we have and divide the following formulas out. There we have container A, which means that we can just do answer divided by the answer of container B, for the volume. Read those questions carefully. This is just a reading exercise. 0.605. Now, we need to multiply that by 100. Why do we need to multiply it by 100? Because a decimal is not a percent. Times answer by 100. And there we have our percent, 6.5. And it's going to ask us to the nearest tenth. Well, we got quite lucky there, 60.5. And you can always visualize it as well, if you have that question, by looking at how much it looks to be full. How much does it look to be full? And this container looks to be more than 50. So yeah, 60.5 seems to be right.